Good day, guys. Welcome to today's video. So what we're doing in today's video is a question on the partial pressure, right? And this is actually a law in the Datum law. So before we start today's video, I want to implore you to subscribe to our YouTube channel so that when I drop interesting video like this, you will also enjoy and partake in it. So let's start today's work. So they said a mixture of nitrogen, oxygen, and helium contains 0.25, 0.15, 0.4 mole of these gases respectively. If the pressure contribution due to oxygen was 2.5 atmosphere, the partial pressure of helium is 4.0 atmosphere, 0.8 atmosphere, 3.3 atmosphere, 2.67 atmosphere. Now, whenever you see questions like this, how do you do them? So this question is actually from Dalton's law. Is from Dalton's law, which says the total partial pressure of one is equals to the partial pressure of the first gas, of another gas, etc. Forever and ever till infinity. So the total partial pressure, you keep adding them. For example, the way we have it here, the total pressure is the partial pressure of the first thing they said here is nitrogen. The second thing they talk about here is oxygen, the partial pressure of oxygen. And the second thing they talk about, third thing they talk about is the partial pressure of helium, right? Right? But here they don't give us the partial pressure of all of them, right? They only give us the partial pressure of oxygen, which they say is because they said here if the pressure contribution due to oxygen was 2.5 atmosphere, this is the partial pressure of oxygen, right? They didn't give us the partial pressure of helium, partial pressure of nitrogen, or the total partial pressure, but they give us the number of moles for all of them. So it means the number of mole also is what? Is the number of mole of nitrogen plus number of mole of oxygen plus number of mole of helium. The way we have it in partial pressure is the way we have it in the number of mole. So what is the number of mole of nitrogen? So that's 0.25 plus number of mole of oxygen is 0.15. Number of mole of helium is 0.4. So that is what? 0.80. So that's in mole. So that's that, right? So now another thing we now want to do is, because they ask us to find the partial pressure of helium, the formula for that is just very simple. What you're just going to do is partial pressure of helium is equals to the number of mole of helium over the total number of mole, which we have found here already, right? That is, you add all the number of mole for all the three gases, then you multiply it by the total pressure, right? Now, because we know the partial pressure of oxygen, we can use that to find the total pressure, so that when we get the total pressure and we have gotten the number of mole of the total and the number of mole of the helium which they've already given us, we'll be able to get the partial pressure of helium. Do you get what I'm saying? What I'm saying is, if we don't get the total pressure, we cannot get the partial pressure of helium. If you don't get the total pressure, we cannot get the partial pressure of helium. So that's what we want to do now. So let me quickly rub. So instead of finding the partial pressure of helium now, I'm now going to find the total pressure using the number of mole of oxygen. So it will be number of mole of oxygen, partial pressure of oxygen. Now let's do that. Partial pressure of oxygen, they gave us 2.5. Number of mole of oxygen is what? 0.15. The total number of moles, 0.8. What's our total pressure? That's what we are looking for. So you multiply 2.5 times 0.8, 0.15, then total pressure. So our total pressure will now be equals to 2.5 times 0.8 over 0.15. So what do we have now? So our answer will be 13.3 atmosphere, right? So now we now apply the formula. Now we have been able to get our total pressure. So now let's get the partial pressure of helium now. Will now be what? Number of mole of helium over total number of mole times the total pressure. So what's the number of mole of helium? That is the so that is 0.4. What's the total number of mole? 0.8. So what we have? 13.33. So at the end of the day, you get 1 year to 2. So you get 6.66666, and that's in atmosphere. Then you approximate, you get 6.67 atmosphere. So that's just how to find the partial pressure for a single. So the answer here is what? Option D. So this thing is not hard. Just familiarize yourself with calculations like this if you are going to succeed in this aspect. So thank you very much for watching today's video, and I want to implore you again to subscribe to our YouTube channel so that you can have access to interesting videos like this. Thank you very much for watching. Bye.